Hello everyone, welcome back to my channel. Today we're going to explore the fascinating world of battery management systems or BMS. BMS is essential for monitoring and protecting batteries in electric vehicles, solar systems, and even your everyday electronics or portable devices. As you can see here, we're going to talk about this board. It's a battery of a scooter, and also we'll cover some kind of BMS architectures and different assembly. As you know, BMS is essential for monitoring and protecting. And by the end of this video, you'll understand what a BMS does, its key components, and why it's so important. So when we say BMS, it's an electronic system that manages a rechargeable battery pack. It monitors voltage, current, temperatures, and SOC of each battery cell. Without a BMS, batteries can overcharge, overheat, or get damaged, which can be dangerous. In the next title, we say about key components of BMS. Obviously, we can have some sensor about voltage, current, temperatures, and in addition, we will have MCU or controller as a brain of BMS, and also balancing circuit, which circuit equalize the voltage across all cells, maximizing battery life. When we talk about BMS functionality, it means for first overcharge protection. The BMS will stop charging if the battery voltage gets too high. Secondly, over discharge protection. It prevents the battery from discharging too deeply, which can damage cells. Third, short circuit protection. It immediately stops current flow in case of a fault. Fourth, cell balancing. It makes sure all cells in battery pack have the same charge level for efficiency. And finally, state monitoring or SOC. And also we have SOH, which means the health, and also temperatures to help maintain battery performance. For example, we have a board here, BMS. It's very tiny, and even it will work with 12 voltage, and it can turn on a lamp or LED. And as you know, we're talking about direct current or DC. We don't talk about AC. Very nice. For example, in this model, we say the safe operating voltage range for these lithium batteries is 2.8 voltage to 4.2 voltage. And when we talk about CC or CB as a constant current and constant voltage, um, we will speak about these options. It begins charging at the constant voltage and low current until the battery reaches above 10 capacity. If the system health conditions allow, the circuit then increase the charging current to speed up the charging process. This continues until the battery reaches approximately 97% capacity. In the final stage, the circuit reduces the voltage and current, charging more slowly to safely bring the battery to full capacity. So once charging is complete, the indicator light changes from red to green, and you can test it. You can buy a BMS module and test all phases of these videos and to influence to your work. In the next section, we speak about schematic or scheme. And as you can see here, we have a BMS model with 10 series and 36 voltage BMS. It's a common architecture when we talk about BMS models, because you will have some pins which is common in all type of BMS boards. So all of them have some um, adjusting system between different voltage. For example, in this board we can have 4 voltage output, 8 voltage, 12 and 16 voltage. So when we have a pin B plus, it means it will connect to battery here. And when we talk about negative B, it means negative pin here. right side. Between battery, we will have some nodes. We call it B1, B2, and B3. So B1 will connect here as a 4 voltage and also another pins. C is our charge pin, and P will use for consumer device. And for example, here we have two as a kind of plate here. It means or C, and also it's P. So we have emerged C and P for this model. And as you can see, it's 4S and 40 ampere sample of BMS board. It's important how we can calculate the title here. For example, when we say 5S 2P, it means we will have 10 cells here, because we have 5 series here and also 2 row or parallel batteries. So P means parallel, and also the sum of our voltage will be about 18, and the capacity here is inserted 3 ampere hours. 3 ampere hours means we can consume 3 ampere in 1 hour, or we can consume for each ampere, and it's a direct relationship between ampere and hours. So the sum of these batteries will be 3 amperes hours, and it's labeled here as a milliamperes hours, and labeled also 3.7 voltage, which some of them will be 18 voltage. So for our work and batteries of a scooter, we will talk about 10S 6P. So we will have many batteries here, and it would be hard for managing batteries and make balance between them. So our BMS model will be very advanced. Perfect. Let me speak about a sample of BMS balancing circuit as a HY2213. On the right side, we have an example application with the P MOSFET models. And maybe, as you know, MOSFET transistors are so really important for us in the circuit of BMS, because they do the main functionality for our BMS model. On the left side, as you can see, it's an N MOSFET of charge balance, and N MOSFET types are so common. For example, here we have some nodes as a B1, B2, B3, 4, and 5, and we spoke about B nodes. Here we have some row, and we have some nodes here. So when we speak about VSS, it means negative of power supply, and when we talk about V2 or VDD, it means positive of power supply. For these connections of the IC, and we call it HY2213, it means we have a capacitor, and it's really important for us because it will be between VDD and VSS, and they place it close to the IC for supply stabilization and noise reduction. And the capacity here is 0.1 microfarad bypass capacitor, and I explained it a lot about bypass capacitors and also impedance capacitors and differences between them, and you can check out the previous videos. Okay, for output control, we need to speak about MOSFET gate drive. So when the monitor cell voltage exceeds the threshold, the IC output is activated. These out pins drive the gate of a MOSFET, controlling whether the balancing resistor is connected across the cells. MOSFET and balancing resistor, or RB. The MOSFET and its corresponding balancing resistor RB are connected in series across cells. When out is active, the MOSFET turns on, allowing current to follow through RB. Let me show you here some resistors. As you can see on the below of the MOSFETs here, we have some resistor here, and it's really important because it will reduce the temperatures of these powered transistors. So this discharge exceeds energy from the higher voltage cell as heat, reducing its voltage and bringing all cells into balance. Typical resistor values are between 100 ohm and 1 kilo ohm, depending on the desired balancing current. For the next title, circuit operation during charging. In normal operation, out remains inactive. The MOSFET is off and current flow only through the normal charge or discharge path of the pack. When self voltage exceeds the set threshold, its IC turns out the MOSFET. The resistor dissipates excess energy. The cell voltage decreases until balance is restored. And please read this section by yourself, and also for safety consideration, it's important to include a pack fuse, NTC thermistor for temperature monitoring, and charge discharge cutoff circuitry in the final BMS design. The top rated batteries type is lithium iron phosphate, and it's really very efficient, and we recommend you to use this type of battery. As you can see, it's really safe and stable. And the next options or replacement would be lithium nickel manganese. If you see the spectrum of battery types from old to future, you will find the old was lead acid, and the next generation was nickel, and then the next generation was lithium, and today we use phosphate and also manganese cobalt compositions. Okay, for conclusion of our prior speeches, we can talk about how we can make a 12 voltage and 3 ampere hour pack. The first section, we need to take 5 cells in series, each rated at 4 voltage and 1.5 ampere hour. Series adds voltage and also capacity stays 1.5 ampere hour. For the next build, another identical series strings of 5 cells, then connect the 2 series strings in parallel. Parallel can add the capacities of 3 Ah, and also voltage stays 20 volts. In result, we will have a battery pack with 3 Ah and 20 voltage. In our challenge, we need to know more about our battery. The battery model 10S6P is a battery of a scooter, and which produced about 2021. As you can see, we need to handle the nominal 36 voltage and the max charge of 42 voltage. So for repairing or charging the battery, for testing and any kind of manipulation, you need to supply or the source of electrician in this range. So the structure here is 10S series and 6P as a parallel. Totally we will have 16 cells. The max charge discharge current will be about 40 amperes, and based on MOSFETs and shunt resistors. You can study the circuit topology by yourself, and I will talk about the diagrams of the board. And as you can see here, we mapped some components here, for example resistors and MCU, and also some regulators. Regulators, you will find it in the left side of the board here. And in my case, faulty condition, charging is impossible. and when I try to take a voltage, output was about 0.04 voltage. Discharge path blocked. Luckily causes discharge MOSFET permanently off. One MOSFET short or open. Protection circuit latch. BMS sinks over current or short happen. And or maybe burnt shunt resistor broken trace near area array of resistors. So we're going to talk about them after knowing what is the model of our battery and what's the structure of the battery. We need to go through MOSFET transistors because they do main functions for switching or increase frequencies. So for first step in BMS models board, we need to test MOSFET transistors. Here we have a model of PE58 and from the package of TO-263, and there are three index here, and it's important for us for finding replacement or any kind of testing. The first is VDS or voltage of drain source, and next is resistance of drain source, and the next is VGS. For example, if we need to find a replacement, if we couldn't find the transistor of PE in the market, we need to find a replacement, and I prioritize it some components here. As you can see, VDS, VGS, and RDS will be common in all of them, and the package is really right here, and it must be 263. Let me talk about MOSFET role in scooter BMS boards. In most BMS boards, multiple MOSFETs of this type are placed in parallel. They are responsible for switching the main battery, and as we call it, about polarity of P or consumption part, providing protection against over discharge, overcharge or voltage, and overcurrent or short circuit. So when any of these conditions occur, the BMS controller pulls down the MOSFET gate voltage. Transistors turn off, and the next battery power is disconnected from the output. For having a review, you can read this section. Practical notes is really help you as we talk about parallel MOSFET, VGS, pin out, pin in, and three important indexes. Before we dive deeper into the MOSFETs or the bank of MOSFET, I can explain differences between active and passive balancing test, which related to resistors. In passive balancing, the BMS simply burns off the extra energy from stronger cells as heat, like a small resistor heater, until all the cells match. But when we talk about active balancing, or means instead of wasting energy, the system moves charge from high voltage cells to low voltage cells, which makes it more efficient for big batteries like EVs. So please have a review what we said here, and for the next part I'm going to talk about and deeper into battery balancing techniques and diagnostics to optimize battery life.